nomenclature for chemistry. And once again, just as a reminder, nomenclature is what we use in order to be able to name the different compounds that we see. So we've been actually working with ionic compounds, which deal with ions. As a reminder, an ion is an atom that has either lost or gained an electron. It can carry a positive or a negative charge. So typically in ionic compounds, you're dealing with metals and nonmetals, positives and negatives, the left side of your periodic table and the right side. Now you're gonna work with covalent bonds. They're actually a lot easier. Covalent bonds don't do or deal with ions. They don't produce positive and negative charges. They're a lot different. So you know how with ionic compounds, you look at your left side and your right side of your periodic table, covalent compounds or covalent bonds actually deal with nonmetals or metalloids. Nonmetals or metalloids, which are towards the right side of your periodic table. So you're actually looking for elements that are nonmetals, typically that are gaseous, or they're transitioning from not being a metal. So you're looking towards the right side of your periodic table. There's a couple set of rules that you're gonna need to follow. These are very easy. If you need to either take a screenshot, a picture, or write them down, they become a lot easier to comprehend with practice, and these deal with covalent compounds. Covalent, once again, just simply think two nonmetals. Ionic is a metal and a nonmetal. Covalent are two nonmetals. So you obviously need your periodic table, the one that we've been using for the last couple of days. Make sure you have that out so you can locate your elements on that table. And then I also want you to have, there's a table, there's like a little graph or a chart that has prefixes on it. And it has like mono is 1, di is for 2, tri is for 3, and so forth. You're probably familiar with those. You might use them like in your math classes or in previous lessons. But I want you to be familiar with those. I want you to have those out so you can understand this a little bit better. So you're going to use prefixes for covalent bonds. That's important for you to remember. Covalent bonds will use prefixes. That's the main difference between naming them from the other types of compounds. You're going to use prefixes. Remember, these do not involve ions, so you're not checking for charges. You're not checking for plus and minus, positive and negative. You're not going to involve ions. They're all going to be on your right side of your periodic table, remember. So there's two terms I want to go over really quickly. I think you probably understand these before, but just for you to be able to comprehend it a little bit better, you have groups and periods on your periodic table. You have groups and periods. Think of your groups as the vertical columns on your table. And that's what exactly they are. They're vertical columns. There's 18 of them. They go 18 of them from top to bottom on your periodic table. Those are known as groups, the vertical columns. Then you have your periods. Those are the horizontal ones from left to right. From left to right, there are horizontal, these are called periods. So groups, top to bottom, periods, left to right. Just so you can understand this a little bit better. Now, the main concept I want you to get out of that is when you're naming covalent bonds, a question is going to arise, well, which one do I name first? If they don't carry a charge, usually with ionic bonds, remember the positive goes first and the negative. Well, if these don't produce charges, which one goes first? Lower group numbers always go first. So whichever element is further left on your periodic table, it has the smaller number when it comes to the group, that one always goes first. Lower group numbers go first. Basically, what that means is the element that is furthest to the left on your table always gets written and named first. Then, let's say that they're both in the same vertical column. They're both in the same group. Which one do you choose? If it so happens that they're in the same group, what you're going to choose is the one with a higher period, or the one that is further towards the bottom of your periodic table. So the furthest left comes first. If they're in the same row, the one that is furthest to the bottom. It's that simple. Those are the first two when it comes to the rules. Once again, groups are vertical columns, periods are horizontal rows. Then you always use prefixes for both names. Remember, you're going to combine both of them because they are binary compounds, so there's at least two elements. You're always going to use prefixes for both, except, you notice the exception down here, mono is not used for the first name. So the first element from 2 to 10, you'll see that there's a chart that names 1 through 10. Well, the first element, you don't use mono. You don't use the prefix for 1. It's just simply the rule. You don't call it 1, mono. I'll show you some examples when it comes to that. It might make a little bit more sense later on, but mono is not used for the first name. If the first name has 2, then it's di. If it has 3, it has tri, and so forth. You can use those prefixes, but mono is not used for the first name. The second name, the second element that is being named always has a prefix, even mono. Whatever it is, the second name always has a prefix. Please remember that. Then you're gonna notice there's another rule that says drop double vowels except di or tri. So what's gonna happen is some of these elements, and I'll show you an example, are going to have double vowels. It seems kind of odd, it looks kind of weird, and sometimes it's redundant. So you want to drop the double vowels. You want to drop the first one and include the rest of the elements, except for di and tri. If you have di for 2 or tri, tri for 3, you're always going to keep all of the vowels. You're not going to drop them. Once again, I'll show you an example of what that means. Now, this last one is an exemption to the rule of the groups and periods. If oxygen, O, oxygen is involved, group 17 always comes before that. Group 17 always comes before that. You notice group 17, which are halogens, those are actually after when it comes to left and right oxygen, but the exception is that O always comes after anyway. So basically oxygen always gets written last. It's the second name in a compound, more than likely. That's what this rule is saying. O is always towards the end, okay? Especially after group number 17. So I'll recap these rules very simply later on. Let me show you a couple examples of what we're talking about. So here on the left, we have the formula for the compounds, and on the right, we're actually gonna have the name. So as you already know, you've taken a quiz by the end of today where it says give the formula for the following compound or name the following compound. This is what it means. Let's start at the top, CO2, you have carbon and you have oxygen. By the way, if you haven't already noticed, let me move on this side. If you haven't already noticed, the second element gets written as if it were an anion. If you recall, the second element, you drop the ending and you add IDE to the end of it. That's the same concept for covalent bonds. It's the same thing. So you're gonna drop your ending and add IDE at the end of the second one. So we got CO2, carbon, and O2, which is, as you can see, dioxide. Now remember the rule where it says if your first one only has 1, you still don't put MONO, mono. You're not gonna call this monocarbon dioxide. It's unnecessary. You automatically assume there's 1 because you just name it as carbon. So you don't name it monocarbon dioxide, just carbon dioxide. Now, the second one always has a prefix. We added Di for 2 because there's 2 of oxygen, carbon dioxide. It's not dioxygen, it's dioxide. Remember, you're gonna drop the ending and add IDE at the end of it. So 1 of carbon, 2 of oxygen, always carbon dioxide. You have to make sure you include the prefixes. Then let's look at the next one. You have I for iodine and you have Cl for chlorine. Same concept. You're gonna see iodine, once again, is not called monoiodine. There's only 1 of them, but it's safe to assume because of the name, there's only 1, you leave it as iodine. And because there are 3 of chlorine, 3 atoms, you would call it trichloride. Again, you drop the ending and add IDE to the end of it. Iodine, trichloride. I want you to notice that iodine and chlorine are actually in the same vertical column. So since iodine is lower when it comes to the horizontal rows, iodine comes first, then chlorine. That's an illustration of the rule we were talking about. They're both in the same row. Which one do you write first? The one that's further at the bottom. So iodine, trichloride. Let's look at another example. We have Br, which is bromine, and you have O, which once again is oxygen. So you have bromine and oxygen. This one, you actually have more than 1 of the first elements. So you're actually going to use a prefix. You're going to use tribromine, tri for 3. And then notice how you have 9 of oxygen. So you're actually going to call it non-oxide. Now, if you look at your chart, you'll notice that the prefix for 9 is nana, N-O-N-A. But because there's already an O for oxygen, you're not going to put Nonaoxide. It's too many vowels. You're going to drop the first vowel, you're going to drop the A, and you're going to add O to the beginning of it. So once again, this is the rule where it says drop double vowels unless it's DI or TRI. You're not going to include the A in nana. It already has the sound with the O. It would be like nana-oxide. You're just going to do non-oxide instead. Once again, 3 for bromine, which is tribromine, and then non-oxide. Remember to drop the double vowel. Then let's look at another example. And by the way, this is also one for the rule where it says group 17 before O. You'll notice that bromine is in 17 and oxygen is in 16. So technically, oxygen is supposed to go first, but oxygen is the only one based on the rules that we have up here where it gets written second. So once again, keep that in mind. Then let's look at another one. We have AS, which is arsenic, and you have O, which is oxygen. Just another example, diarsenic, which is 2 for arsenic, and then you have 5 for oxygen, so it's pentoxide. You'll notice once again on your prefixes that 5 is penta more than likely, so you're going to drop the A and you're just going to add O once again because it's the same sound. Even though it's an A and an O, it's still the A sound. So you're just going to call it pentoxide. Diarsenic, pentoxide. Then let's look at our last one. You have N for nitrogen. You would not call it mononitrogen once again because you don't add mono to the first element. The last one is 3, so it's triiodide. Triiodide. This one, because it's tri, you still add the I. So there's 2 I's there, triiodide. Once again, nitrogen, triiodide. You have 3 of it. These are just examples of many that you're going to see. The rules are simple. Just stick to your prefixes. The first, just very simple set of rules. They're easy to comprehend. You just need to practice. Once again, these are covalent compounds. These are the last set of your worksheets that you have. Everything else should be done, or you should be finishing it at this point after listening and looking at this lesson. You should be able to understand nomenclature as a whole. You should be able to finish all of this homework. I need that done by Thursday